Hello world and welcome back to Marnie Makes Games. A few months ago I made a little video about creating a spider walk animation using IK and raycasting. One of the commenters on that video actually challenged me and said, well, why don't you do this in 3D? Having never done 3D before, I thought, you know what, this would be a good challenge for me. So I've taken it on and I'm taking you with me. Follow along as I create this 3D spider with an IK walk animation. Ready to go? My name is Marnie and I make games. In this video, I'm just quickly going to talk about how my spider is set up and how I got it to move across the terrain. Now, this spider is from an asset store asset that I will link down below. It's free, so feel free to use it. When I drag the prefab into my scene, I notice that the coordinate system for this is not the way I like it. I like to have my Z-axis facing forward. So all I did is I completely unpacked the prefab and then I went to this and I created an empty parent for it. Then I oriented the parent, called it spider body parent, to face with the Z-axis forward and the Y up and the X-axis facing in the right-hand direction. Then I just moved my spider to basically match this orientation despite what its coordinate system says. That's all. Then I added a script to this spider body parent, and I have a good reason for moving this separately from this, which will become clearer in my later videos. Then I also added two capsule colliders. Now, why do we add two capsule colliders? Because if we add one capsule collider without constraining our rigid body's movement, it will move across the terrain, and then as soon as you turn, the spider will roll over, because that's what a cylinder does. So I put two cylinders next to each other. Why the cylinders or the capsules? That's so that if the spider hits an obstacle, it will automatically rear up and over the obstacle instead of getting stuck like you would with a box collider. Right, after that, I added a play input from the new Unity input system. And then I added my own body script, which we'll have a look at now. Now in the body mover script, I specified the forward move force, the turn torque. This is the force for moving the spider and for turning it. The max linear velocity, that's the speed limit for our spider. And the max angular velocity, in other words, the maximum rate at which it can turn to prevent our spider from spinning after a while. And then vector 2 will be storing our current input from our Unity input system, and I've initialized that to 0 just in case. At start, I just grab the rigid body, then I set the max angular velocity and the max linear velocity for the rigid body from this. And then in fixed update, because we're working with physics, I went to rigid body and I added a force in the direction of transform.forward, multiply that force by the forward move force, and time.fixed delta time to keep it consistent across platforms and performance levels. Then I also multiplied it by current input.y. Now, in the new Unity input system, this is essentially just the vertical axis of your input. And I used force mode.acceleration, which ignores the mass of our spider and gives me a little bit quicker response when I try to move or turn. Then I just declared a public function on move input, which takes in a callback context called context, and I use that to read the vector2 value from the input and store that for use over here. So basically what happens is if your input changes, this value changes, which means that this value changes. So it'll always be multiplying by this. Now let's say I just push forward, then current input y will change to 1, or if I push backwards, it'll change to -1. Otherwise, if I'm not pushing a button, it's going to be 0. If you've got an analog control, that's going to be a value between -1 and 1. So basically what happens here is if I take all this and I multiply it by 0, I get nothing and the spider doesn't move. Anything else than 0, it moves forward or backwards. Same applies to the torque for turning our spider. Then lastly, if you're using the new Unity input system, please remember to say using Unity Engine input system input action. That's going to give you that callback context over here. Back in the editor, if you look at your player input, I've set the behavior to invoke Unity events, and this event gets called every time the input changes. And then I went there to move callback, drag my game object for my spider in here, and just went to the body move script and selected on move input. And that's it. Now you've got a spider that can almost move. One last thing to do though is when you're in play mode, go to your script and tweak your forces until you get the desired reaction from your spider. So in my case, I had to use a forward move force of 700, which gave me a spider moving at a good clip, while I still limited the max linear velocity to 6 and the angular velocity to 5. And then the turn torque, I'm using 2000 as a turn torque. That gets a nice snappy turn out of the spider. But because I'm limiting the max angular velocity, you can see the spider doesn't go off spinning after holding down the control for a while. That's it. Our spider's all set up to move across the terrain. In the next video, I'll be showing you how to set up the bones and how to rig the IK for the spider. Until then, I am Mani and I make games.